Question 12, Part B. Let f of x equal the square root of 4x minus 3. Part 1. Find the domain of f of x. The expression inside the square root, that is 4x minus 3, has to be greater than or equal to 0. So we can solve this inequality for x. So moving the negative 3 over to the other side becomes positive 3. The inequality becomes 4x is greater than or equal to 3. Dividing both sides of the inequality by 4 to make x the subject, we get x is greater than or equal to 3 over 4. Part 2. Find an expression for the inverse function, f inverse of x. Let y equal the square root of 4x minus 3. Now in part 1, we found that the domain is x is greater than or equal to 3 over 4. And the range is y is greater than or equal to 0. And it's also a one-to-one function. That means the graph of y equals the square root of 4x minus 3 will pass both the vertical and the horizontal line tests. That means the inverse of y equals f of x will itself be a function. So to find the inverse of y equals the square root of 4x minus 3, we swap the x and y variables around and then make y the subject. So the inverse is given by x equals the square root of 4y minus 3. Squaring both sides to cancel the square root function on the right hand side, we get x squared is equal to 4y minus 3. Adding 3 to both sides of the equation to cancel the negative 3 here, we get x squared plus 3 is equal to 4y. And then dividing both sides of the equation by 4, we get y is equal to 1 over 4 times x squared plus 3 in brackets. Now just want to go back to the domain and range of y equals f of x. The domain of y equals f of x becomes the range of the inverse function, and the range of y equals f of x, which is y is greater than or equal to 0, becomes the domain of the inverse function. Hence, f inverse of x is equal to 1 over 4 times x squared plus 3 in brackets, where x is greater than or equal to 0. Part 3. Find the points where the graphs y equals f of x and y equals x intersect. To find the points of intersection between the graphs of y equals x and y equals f of x, we solve x equals f of x. And in this case, our f of x is the square root of 4x minus 3. So we're solving the equation, the square root of 4x minus 3 equals x. Squaring both sides of the equation, we get 4x minus 3 is equal to x squared. Then moving all terms over to one side, I'm going to move the 4x minus 3 over to the right-hand side to form a monic quadratic equation. So we get 0 is equal to x squared minus 4x plus 3. Factorizing the right-hand side, we get x minus 1 in brackets times x minus 3 in brackets equals 0. And the solution is x equals 1 or x equals 3. Now, these are points on the line y equals x, as well as on the curve y equals the square root of 4x minus 3. So the x coordinates and the y coordinates will be identical in this case. So the graphs of y equals x and y equals f of x intersect where x equals 1 and x equals 3. Therefore, the coordinates of the points of intersection are 1, 1 and 3, 3. Part 4. On the same set of axes, sketch the graphs y equals f of x and y equals f inverse of x, showing the information found in Part 3. Here is a sketch of the graphs of y equals f of x, y equals f inverse of x, and y equals x, shown on the same set of axes. Note the 2 points of intersection that we found in Part 3, that's 1, 1 and 3, 3. Also note the domain that we found in Part 1 for y equals f of x is x greater than or equal to 3 over 4, and the graph starts with an x-intercept of 3 over 4, and the range of y equals f of x is y is greater than or equal to 0. And the shape of the graph is like this. Now the graph of the inverse, y equals f inverse of x, is a parabola, y equals 1 over 4 times x squared plus 3 in brackets. And it has a y-intercept of 3 over 4, which is the x-intercept reflected in the line y equals x to give us the y-intercept of 3 over 4. And it looks something like this. Notice that it passes through the points of intersection 1, 1 and 3, 3.